Find the standard deviation S of sample data summarized in the frequency distribution table below by using the formula below, where X represents the class midpoint, F represents the class frequency, and N represents the total number of sample values. Also, compare the computed standard deviation to the standard deviation obtained from the original list of data values, 11.1. We have a formula here for calculating the standard deviation for a grouped data set, but it really isn't necessary for us to use that formula since we have StatCrunch available to us. So we'll begin by clicking on the box and then open in StatCrunch. A StatCrunch table will open, and in order to find the standard deviation, we'll click Stat, Summary Stats, and then we'll go down to Grouped Binned Data, because that's what we have, is data that's grouped. The bins, or in other words, the classes, are in the column titled Interval, and the counts are in the column titled Frequency. What we want is the standard deviation, so that's what I'll click and make sure is in my output box. Click Compute, and we get a standard deviation of 10.3 if we round to 1 decimal place as requested in the problem. Now let's look at what the rest of the question asks us. Consider a difference of 20% between two values of a standard deviation to be significant. How does this computed value compare with the given standard deviation of 11.1? We are given a representative table where the data values have been summarized. So in other words, we don't know exactly what the data values were between 30 and 36. We only know that there were two of them. And we know that there was one value between 37 and 43, and we know that there were 7 values between 44 and 50 and on down. So let's suppose for a moment that the two data values between 30 and 36 were 31 and 35. And let's suppose for a moment that the data value between 37 and 43 was 40. And let's suppose that the 7 values between 44 and 50 were 44, another 44, a 45, a 46, a 47, a 50, and another value. And then we could continue this on through the rest of the table. Recall that the standard deviation that was estimated from this grouped frequency distribution was 10.3. We were told that the standard deviation for the actual data set was 11.1. The question is the standard deviation estimated from the grouped data within 20% of the standard deviation of the actual sample values? In order to answer that question, we would just do a simple percentage difference calculation. The question says, is the standard deviation estimated from the group data within 20% of the standard deviation of the actual sample values? So we're doing a percentage of the standard deviation of the actual sample values. So when we divide in this calculation, we will make sure that we divide by the sample standard deviation of the data values. So our calculation will be to subtract the sample standard deviation from the estimated sample standard deviation, divide that by the sample standard deviation, and then multiply that by 100%. So we'll have 10.3 minus 11.1 divided by 11.1 times 100%. And when we do that, we get a negative 7.2%. And we would interpret that by saying that the standard deviation that was estimated from the group data is 7.2% less than the standard deviation of the actual sample values. Recall that the question said, consider a difference of 20% between two values of a standard deviation to be significant. 7.2% is less than 20%, so the correct response should be the computed value is not significantly different from the given value.